Hello, good evening. I believe some of the students who are engaged in this course are available and are likely to join at some stage or the other. Based on the last 2.5 weeks, some queries which may have come and possibly whatever doubts may be there. So we'll try to work on them and hopefully make the course more interesting. In the meantime, if some more people join and ask any questions, we may like to take that question also. Let me begin with the agenda. And the agenda will be that we would try to look at some of the doubts in the beginning and later on take some more questions. An interesting part of the whole textile chemical processing is singeing. There was some questions based on the singeing itself. So singeing basically is a process for removing any protruding hair or of the fabric which is appearing, let's say, on any surface. If you look at the microscope, you will see, or even a naked eye also, you can see sometimes the hairs are protruding. Those protruding hairs invariably for many processes are not desirable, certainly not for printing. Even if they are there during dyeing or bleaching or any other such process, they may create additional friction between materials flowing on the guide rollers and rubbing against each other, and may create some kind of balls, pilling, and all such things can happen during the processing. So it is always better to remove these protruding hair as early as possible. The earliest possible is a gray fabric. As the gray fabric comes, one can remove. It is also been understood if the fabric is wet, the singeing process generally done by hot plate or flame, direct flame, is not a good idea to do it on a wet fabric. So if you also do any process which is wet, and then you'll have to dry again. A gray fabric by itself is very dry. Why the hair are showing is because during the weaving process, there are a lot of motions which take place, relative motion of the yarn, which obviously remove some of these fibers more than what can be done. So we have to remove them. When the fabric is dry, it is easy to remove these fabrics. When it is dry, it is easy to burn out, and also degradation is going to be less. In case some yellowing also takes place, it's possible that during bleaching and other process that yellowing can also be removed to a certain extent. So that is why we would like to do the singeing, which has to be done. And after that, we can do any process that we want to work on. So that's the singeing part of it. After singeing, we have a process which is desizing. And this desizing process is an important process again. And why do we say it's an important process? Because we consider that during the process we had applied size, which is a polymeric material, And so it has to be removed, because the purpose of size was only restricted and was to the weaving process. And if the weaving process now is over, and if some of the films are always remaining on surface, obviously it is not good. This must be removed. So we call it a necessary evil. The sizing is a necessary evil which the chemical processing, during the chemical processing, it has to be removed. So this is one. I'm just trying to take these some of these topics only because some of you said that you do not have or did not have the background of textile chemical processing. Right? Therefore, we thought we can consider this as an opportunity to just revise a bit. Mercerization is also an important process. Not necessarily every fabric, obviously, cotton fabric we're talking about is mercerized. But this process is carried out in a very strong alkaline solution, which is caustic, 18 to 20% caustic solutions. And almost permanent changes take place in the fiber, cotton fiber particularly. The fiber becomes much more rounder. The crystalline structures also change. The reactivity of the fiber also improves. And because of the reactivity improvement, higher dye uptake, but more than that, the lustrous appearance of the textile is an important contribution of a mercerization process. It, of course, costs money. After you have done the mercerization, you have to do a lot of washing. The many washing cycles have to be done before all the alkali can be removed. And after that, you can take it for any process which is dyeing or finishing, if it is, or bleaching for that matter. Sulfurization is actually a finishing treatment which should be done actually while you are finishing it finally. It can be done, it should be done after dyeing and printing and all such processes are over. And this is also an important process because, and particularly for the cellulosic based material, cotton to begin with, which can shrink during washing processes. And if you remember, the shrinkage can be due to stresses or stress relaxation. Stress relaxation, or it could be due to what we call as swelling. So this shrinkage which the sulfurization takes care is the shrinkage which may take place because of swelling. And this is more important for such fibers which in water change the diameter. If the diameter of the fiber increases, and then because of this shrinkage takes place because of swelling, that type of a shrinkage is called the shrinkage due to swelling, which can be reduced to quite a degree if sulfurization process is done. It's like a pre-shrinkage process where we have compressive shrinkage. So compressive shrinkage is what is given to the fabric, and in a manner which ultimately leads to accommodating situations of due to shrinkage. For example, this yarn, let us say, is passing over warp and weft, and if this yarn, which is, let's say, yarn A, swells, the diameter of this would be larger, and because of that the other yarn has to traverse a larger path, and so there will be contraction, and this is what we call as a shrinkage due to swelling. And sanforization is one process which can very easily reduce this tendency, because by doing the compressive shrinkage, extra space is provided where swelling of the hydrophilic fibers can be accommodated. I hope it is becoming more and more clear. There could be some confusions in some places where the definitions sometimes can be issue, particularly for the people who may be learning this for the first time. A percentage shade is of any dyed fabric. So when you dye fabric to a certain amount of dye, which is, let's say, on a mass basis, milligrams of dye per gram of fabric, or we can say gram of dye on 100 gram of fabric. How much dye is present on 100 gram of fabric? Let's say if it's a 1% shade, that means we believe that 1% of the dye is going to be added to 100 gram of the fabric. So when we do the exhaust processes, exhaustion process actually means that there is a liquor, dye liquor, which has got a certain amount of dye, which must completely get exhausted onto the fabric. So if suppose we have 1 gram fabric and we have 100 ml of solution, and so one would say, well, this is called 1:100 ml ratio. Then how much dye one should take in this 100 ml, which will be completely exhausted? If about 1% shade has to be produced, that this 100 ml should have only 1% of the fabric weight. That is what would mean. And so one calculates how much dye has to be, right? So you can have the concentration of this exhaust process dye liquor, which is very lighter. Very small concentrations are used because everything has to be absorbed onto the fabric finally. Normally it may not happen. 100% exhaustion may not take place, maybe 90% takes place. Our aim would be to exhaust as much as possible. Whatever is not exhausted, for various reasons, would be generally, in some sense, is a waste. On the other hand, there is a padding process, which you use a padding mangle. And padding mangle will first, you have a bath through which the fabric passes, and then you squeeze it. When you squeeze, how much you squeeze is going to determine how much is retained on the fabric. So if suppose 1% shade is to be given through a padding process, and an expression is what we call as 100% expression, which would mean is that 100 gram of fabric, if picks up 100 gram of solution, 100 gram of fabric, 100 gram of solution, then we'll call it 100% wet expression. All right. So if you squeeze more, the wet expression can be less. Therefore, to get the same shade, you may have to add more dye. And this depends on why should it be 100% and why should it be less than 100% will depend on the requirement that the process house will set up. So based on these, one can always find that the concentration of the liquor in a padding solution for the same shade is going to be very high compared to the concentration in an exhaust process. I hope this would be clear, and one can always calculate those bath concentrations, and depending upon the shade percentage, one can prepare. The ml ratio becomes important in exhaust process because different machines require a different ml ratio. Some require high ml ratio, others require low ml ratio, and therefore the concentration of the dye bath will keep changing. But in general, one can expect the exhaust process would have lower dye concentration generally compared to a pad process. Then there's something called a shade matching in a dyeing. When you dye a material, all this exhaustion expression will have some bearing on what shade actually is going to be on the fabric. And why the shade matching is required is because there may be a requirement of a customer to provide a certain amount of shade of a dyed material. And then the processor has to work around either based on exhaust process or based on the pad process, how much dye has to be added. What expression has been kept, and based on that, as well as the efficiency of transfer. If everything is good, accordingly, concentration will have to be changed. But it may also happen that despite all the nice things, the calculation, the shade may not match. Reason could be the dye or a combination of dyes which may have been used by the client before. You are not using the same dye, or the purity of the dye is not exactly same, because dye which is available is never 100% dye. There are additives in that, and based on that you may actually get some different observations. So you have computer color matching systems which will measure the color on the sample which has been provided. Then the process house would do the dyeing based on their experience and understanding. Then the sample prepared would be tested, and if there is a difference, one has to rectify the dye concentrations in a manner that finally it matches to a level which is an acceptable level. Okay. This is an important part, which is generally a common practice in any process house. They have to do it every day. So when it comes to printing, as against the dyeing, this whole process becomes much more difficult. The shade matching is not easy because of the design itself. There are different colors on the same fabric. The shapes and the sizes of lines in the design are very different. Measuring by any equipment, spectrophotometer is also not easy. If a very fine line has got a very different shade than the rest of the thing, then measuring that area is not a very easy thing. A dyed fabric is a fully dyed fabric you can measure anywhere and try to get averages out and look into then the shed matching issues. So because the sizes, different colors, shapes, which may not really match uh, the, the the requirements of the equipment itself, and therefore it is not easy to match. The other is the depth of penetration. In the case of dyeing, you go for complete penetration, reach to an equilibrium state, and then if everything is good, 100% absorption is there, adsorption is there, then and uniformly also, then we expect whatever you have taken will be uniformly distributed, and then you can talk about shade and work it out. Here there is general expectation. The back of the fabric would not have color at all. And so how much it has penetrated? 20%, 25%, 75%, 50%. Based on that, the actual appearance of the shade will be there. So if somebody actually wants to say, well, I like to work around and find out how much percentage, you don't even know how to express it. Are you going to express it per unit weight of the fabric? Are you going to express based on the area of print? So if the print is a very big design, you can always talk about it. But if the print has got fine lines, small lines and different colors and different depths of penetration depending upon steaming time itself. And therefore, printing is a difficult process. And invariably, obviously, by experience, you do whatever matching is to be done. And the ingredients also are a large number, and therefore it doesn't remain an easy option for anyone. So there are difficulties in all levels. So one of the other interesting difficulties that one has is washing. When you want to wash dyed fabric, there is one shade, one color, or a mixture of color, which is everywhere on the fabric, which is same. So during washing, if color comes out, well, it goes into solution. There is some loss, but still the fabric would be appearing as dyed uniformly. However, when you want to do the washing of a printed material in the beginning, so unused color, unused material has to be removed from different print areas, and they have to get to the washing liquor. When it flows, the colors of one portion can flow over the other print design and even the white portion where there is no color. And there is quite possibility that if care is not taken, some little tint of a different color could appear at different levels, and therefore the shade could be different. And it may finally not look very aesthetically nice. So washing of a dyed material is much easier compared to washing of a printed material, and the one really has to be very careful how the washing has to be done. So printing is difficult, and after printing the washing is difficult. Then of course drying, etc. is not so much of a problem. So because printing is a difficult process and relatively much more costlier process, and you need many more experts to do the job. So people may have a tendency to use dyes which have good fastness properties. The wet dyes are quite preferred class of dyes in printing, although printing and dyeing both of wet dyes is more complex. And still, wet dyes are used because the wash fastness is very high. Because generally, this is at a very high level of generally 5 or 4 to 5, 4.5. That kind of a wash fastness is there, and light fastness generally are also very high. just to make the life easy, because the wet dyeing and wet printing process involves reduction and oxidation. These are the two important things that take place, and therefore printing with the wet dyes is more complex. So there's another class of dye which is called the solubilized wet dye, where wet dye has been reduced and stabilized in a manner that it would not get uh, will become insoluble and remains in soluble form for a long period of time. And therefore, uh, some of these dyes are also used for printing purposes. However, after printing and after oxidation, it is the same dye as the previous wet dye, so there's no difference. So all fastness properties remain same, except, of course, this will be more costly dye. Discharge style of printing is a very interesting style of printing. Whenever one has dark background fabrics and you aesthetically prefer a very dark background fabric and smaller designs to be created, then it is preferred that you first dye the fabric and then remove color from the portions which you believe should be different. So one can discharge or destroy the color to an extent that the fabric areas may appear white in case you want. This also a pretty difficult process, and one has to take additional care. But if smaller designs and sizes are there and large backgrounds are dyed, then direct style of printing is not a good idea, and so one uses discharge. So additional chemicals now come into picture, like reducing agents have to be used, which are stable enough in a printing solution, printing paste, and so that makes slightly, but it's a very beautiful style, and people like to use this style of printing. Then dischargeability has been defined based on the ease of discharging. So dyes generally may be put on a scale of 1 to 5. The ones which discharge very easily, relatively easily, we may be having a dischargeability of 5 or 4 to 5. These type of dyes are good for white discharge. If you have a color discharge, you can probably afford, even if it is not completely white after discharge, because it's going to be replaced by a different color, right? And if illuminating color, that means color discharge has to be produced, then the dischargeability of that dye would be in the tune of near 1 or so. That means under the conditions of reduction generally which is used, these dyes would not be easily changing any color, that they will not get destroyed. It's not changing color, but it's a destruction color, so you can wash it off and then get a ground different. So discharge printing therefore is important, that on a colored material you cannot, dark colored material you cannot print something else because it will not be visible. Like for example, you want a light lemon on a dark black or a blue, it will not be visible. So you have to remove the color from certain areas and then put an illuminating color of whichever type that you want, which has got low dischargeability. So dischargeable colors, some of the dischargeable colors uh, are the ones which can be destroyed by, easily destroyed by, for example, a reducing agent. Some of them either could have an azo group very easily, but in some cases, like reactive dyes, you have ramazols or vinyl sulfone based dyes which are used on cotton or viscose. They can be relatively easily discharged. Illuminating colors, as we said, on the other hand, could be uh, basic dyes, could be there, or highly non-dischargeable wet colors could be there, which can, as I said, dischargeability is low, and which will be used along with the paste itself, which reduces the background color, and the illuminating color can then be seen later after fixation and then washing. One other important component other than the color, obviously, is the thickening agent. Now, thickening agent is interesting because needed also because the color must not flow out of the boundaries that have been defined by the design. And therefore, a thickening agent has relatively high viscosity. And this is compared to, let's say, dye bath, is very, very high viscosity. And therefore, this will not allow the color to leave the boundaries till fixation is complete. So during printing process, you have a high viscosity, different colors being printed one out of the other, one after the other, and let's say 4 or 5 colors have to be done. So all 4 or 5 colors have been printed. Various process of printing, the screen printing or roller printing. But high viscosity liquid would find it very difficult to pass through a mesh. And so it is desirable that when, let's say, a shearing process is performed like a squeegee on a screen, the viscosity must come down, which is very interesting. And such type of materials are the ones which are obviously preferred for printing, where if one plots a rate of shear you increase this and measure viscosity, it will come down. And when the shear rate is reduced, it should also go back to the same position. So both these things are important. When you increase the shear, the viscosity goes down. When you reduce the shear, it should go back. Now, what it means in practical terms is that when there is no shear taking place and the paste, printing paste, along with everything else is lying on the screen, then it does not automatically pass through the mesh. And so it stays there on the top of the screen. But when you apply a shear, the viscosity goes down, it very easily passes through the mesh and gets transferred onto the textile. When you remove the squeegee shearing force, then the viscosity again comes back. So it's a process which obviously increases. There you see the decrease in viscosity, you see the increase in viscosity every cycle of printing. And therefore, such type of polymeric systems which are used for creating a printing paste, or some called sometimes thickening agents, to show a shear thinning behavior. There are some material which will show the reverse behavior as well, which will be shear thickening, but they will not be obviously suitable for any printing processes. So it's a very interesting property. Sometimes these kind of properties are also studied in the term called the rheology of pastes, and one can measure these and then see, select material which are suitable, and they exhibit this type of a process. There is a similar style which is called the discharge resist style. Resist style, you understand, is where certain amount of mechanical or chemical resist is applied so that the dye either does not penetrate or gets destroyed before diffusion. All right, so that's how the resist style is there. Some material like polyester, for that matter, which generally use disperse dye. Polyester obviously is not hydrophilic, so it has to be dyed also at a different higher temperatures and pressures. And if you use a discharge style of printing after dyeing, it becomes much more difficult to remove the color from whatever we do, the steaming and other processes that we have for destroying the color after putting the discharging agent. Sometimes people prefer, why allow the dye to first fix? We want the dye to get fixed all over, but during the process of printing itself. So one of the ways would be that first you print the design using a resist, which could be a chemical resist with a discharging agent. Then you put a print again with a blank screen, for that matter, which goes very easily all over the fabric, and then you fix it up. When you fix again, then one finds that the dye penetrates during steaming or fixation process, and wherever the dye is, wherever the dye encounters some design where discharging agent is available, there the dye obviously get destroyed and it does not penetrate anywhere. So you get a much better, clearer effect. So in a way you are resisting and also discharging. But the discharge is now taking place before the dye has penetrated. So it is much easier and cleaner discharge, better whites can be obtained by this process. Then we have some interesting things called the pigment printing. Pigment, as we already said, somewhere it does not have uh, any affinity for the textile. So in one way you may say it's a difficult thing, but if you use a binder which is a polymeric substance, makes a film. These pigments can be trapped. Advantage obviously is that irrespective of whether it is cotton, viscose, polyester, nylon, acrylic blends, binary blends, tertiary blends, whichever kind of fiber, whichever number of fibers you can use in the fabric, and you can still print from a pigment printing process. So it's a very interesting printing technique, and they. But what one has to clearly understand is that because there is a binder which is going to trap the dye pigment particles, because they are actually particles. They can be smaller in size, but they are particles. While during the previous printing and period dye, we were talking about that everything was happening at a molecular level. The dye was getting dissolved. Even in printing, the dye was first becoming a solution and then getting inside the fiber. But pigment printing obviously means the pigment remains as a pigment which doesn't have affinity and remains as a particle, and the particle has to be basically fixed by a binder. If you use the normal thickening agents, the way we are using for the other printing processes, which after fixation are supposed to be washed off, in this case, the binder will fix them as well. And therefore, the binder will trap the pigment as well as the thickening agent is also. So obviously the perception of the color is going to be very poor, and fastness properties also may be affected quite a lot, the wet and dry rubbing fastest. Therefore, for pigment printing, people have been thinking of a thickening agent which has no solid content. A thickening agent which is zero solid content. And one of that example was oil and water emulsion. You must have seen when you mix up oil and water, the viscosity of that emulsion increases suitably. But when you fix it up, the water evaporates as well as the oil evaporates, and therefore nothing remains on the fabric. What remains is only the pigment and the binder, which obviously binds the pigment. So this was the concept of a zero solid thickening agent. Only because of the environmental concerns and also of fire safety, because some of the oils which are being used, like a kerosene oil for that matter, they are flammable compound, and resistance to the fire is, or the damage due to fire or risks of the fire taking place are there. So people thinking of something else which is similar to zero solid thickening, similar to the oil water emulsion thickening. One of those examples called the synthetic thickeners. Now, this believes in a principle where a polymeric electrolyte is there, which is called the polyelectrolyte, that even on one molecule, many groups are there which are, let's say, ionic, negative or positive. If such molecules come together, there is a tremendous amount of repulsion, and because of repulsion, viscosity gets created. And what is important in this case is that very small, very small amount of solid, if dissolved, can create a very high viscosity at a suitable pH. So they are pH sensitive systems. If pH changes, then one may say the viscosity reduced tremendously. But at an appropriate pH, you will see that viscosity is very high. They have in some sense replaced uh, the emulsion thickening because the total weight is less. So if somebody says that they still have more than zero solids, yes, they have. And if that gets trapped, that will certainly get trapped. But because the the total amount of solid content is very less, the perception of the color does not change very very much. And so sympathy thickeners have become very important for various reasons, and this is one of the reasons one day. One point of reactive dyes, very important class of dyes, which obviously binds covalently, and because it binds covalently, therefore we we expect wash fastness to be very high because during washing, breaking of covalent bonds is not easy. However, it is known that the wash fastness in general are not the highest, despite that theory says it's going to be covalently bonded. And that is because of a dye which becomes hydrolyzed before reaction. Why is that? Under the condition of reaction, let's say with cellulose, the hydroxyl group of cellulose was supposed to react with the reactive dye in a water medium or an aqueous systems. So why should the hydroxyl group of the water not react with the dye? Obviously it does react. That becomes a hydrolyzed dye. This obviously after hydrolysis cannot covalently link with the fiber and stays on the fiber without reaction. And every time one dyes or one prints, part of this dye gets hydrolyzed. One has to be very careful as to reduce the hydrolyzed dye because hydrolyzed dye will keep coming out during all washing cycles, and so one will see that the fastness may not be as high as seen. That's one of the reasons why, unlike all other dyeing systems, printing systems, the substantivity expected uh, of the reactive dyes for the textile substrate is not very high because once it is covalently bonded, then it will not come out anyway. And the one which gets hydrolyzed, we should be able to wash it relatively easily. And therefore, substantivity on reactive dyes may not be we don't expect it to be very high. There is no point. But at the same time, one should remember that today it is not cellulose which can be dyed or which is being dyed by reactive dyes. Silk, wool, nylon can be obviously dyed with reactive dyes, and the pH requirements for the dyes and fixation is very different. It is not alkaline, and therefore hydrolyzed dye formation also is reduced or eliminated altogether if you dye silk, wool, and nylon. So that also is an information which may be useful. But for cotton, cellulose, and other cellulosic material, one may have to still go in for the alkaline medium. And it is not the water which was there to do the hydrolyze, produce hydrolyzed dye. But other thickening agents may also have hydroxyl groups. So the reactive dye can react with the hydroxyl group of cotton as well as hydroxyl group of the thickening agent, which obviously will be permanently wasted because thickening agent has to be washed off. So one of the interesting product has been for the making of printing paste sodium alginate, which has carboxyl groups rather than hydroxyl groups. And therefore, reaction with the covalent reaction at that condition, which is the alkaline condition, doesn't take place. And so, if cellulose-based materials have to be printed, then sodium alginate is one of the interesting thickening agents which people have been using. Natural product, but similar synthetic products also are in the market. But one must remember reactive dye to be printed on cellulose and other fabrics, viscose fabrics, would require alkaline medium. Chance of hydrolyzed dye will be there, but at least one have to choose thickening agent which does not react with the reactive dye. The other interesting thing which you have probably learnt a bit in the last few weeks is the transfer printing. Now, the transfer printing, although still is not commercially, doesn't have that large a market, but it is very advantageous. That is, if you print a paper, transfer the design onto the textile, all various process, once the fixation takes place, don't have to do washing and drying. A dry transfer means you're just heating, and the molecules, obviously from solid, they go into the vapor phase and diffuse into the fabric, which is also more accessible because temperature high. It was a very interesting thing which happened was obviously the dispersed dye sublimes, and polyester loves dispersed dye. So transfer printing of polyester became one of the more successful stories in printing. Photographic images are printed regularly because of various techniques that you have probably studied here also. And once the photographic image has been printed, then the same can be transferred onto the textile very easily. If you go by conventional printing systems, if you have 8 colors uh, design, then you have 8 screens, 8 rollers. But a photographic would require hundreds of thousands of such screens, which is obviously not possible. And therefore, transfer printing gives a beautiful solution to this. Important thing is, as we said, these dyes sublime. Because these dyes sublime, uh, therefore, it is good for us that without uh, washing, one can complete the printing process. While the compromise is that there is something called a sublimation fastness, which obviously will be compromised. If you have high energy dye, they will not sublime very much. If you have low energy dye, they'll sublime quite a lot. But they can have poor sublimation fastness as well. So a compromise has to be made where middle energy dyes have to be used to get this done. Can cotton be transfer printed with dispersed dyes? So we've studied, yes, if you can change the surface of a cotton or cellulose fabrics with hydrophobic material or films and polymers and layers, then one can do the transfer of dispersed dyes by thermal transfer printing. Some questions were being asked as to how to answer the assignment while the videos are to be watched, but remember, You have 2 or 3, 2 hours, 2.5 hours, 3 hours of video per week. And therefore, it is possible therefore to you can study separately like you study initially and then answer the questions, and you have enough time to complete those questions which are just there to see that similar small information, the concept which have been provided in the lectures are understood. So neither the assignments are very tough, and they're just checking, and you have enough time to go back, so that should not be a problem. The other thing which I like is that you should be able to use the forum. Very few people are using the forum. If you use the forum correctly, some of the doubts can be cleared, and one can understand the subject more in some manner. So this is what I thought you would like to know, and in case you have, some people were looking at the transcript. And the transcripts, whenever are going to be available, will be available, but don't depend on them. So don't depend on transcripts. However, when you have free time, we're not looking at exam, get some paper, print it with any type of dispersed dye, make a transfer paper, take a normal iron or a half pan press, and use this to transfer the print. See how good it is. Similarly, you can make a solution of a starch which is available at various places and check whether it is shear thinning or shear thickening. You may try at home, anywhere, tie and dye type of a printing process and see if you can create interesting designs in this respect. So we will be stopping here now, and I don't think there are any other questions which have been raised. So in case they are there, please use your forum and try to ask any questions. We'll try to work on it. So thank you very much, and hope you keep going through the rest of the weeks and also the assignments, and hopefully some of you may be wanting to take a final exam also. All the best.